Yo, yo. Say hello, cat. Welcome, everybody. I do wonder why I say welcome everybody before everybody gets here. What else are you gonna say? Sweet, sweet, let's go. Aircon, it's a bit warm. Okay, so I got the asymp loader working. I had to update on NuGet, which is Visual Studio package manager. I had to update the asymp version, which took an hour and a half. Yeah, yes. I fixed the viewport, so now the clouds, the skybox it's called, will take up the full screen. As you can see, so if you're looking, you're now looking at, and if you pay attention, you can see the clouds are moving. Also, can I do this? Oh, nice. Yeah, I really need to fix that. So the sun function happens upon all of the animation, all of the 3D models loaded. But so don't try and change the color of the sun before you load a model, basically. What is this old model anyway that I've not done anything with? It's just so messy, really. It's some sort of house model. It's too big as well. Who's modeling this big? But you can't even see the end of it. Yeah. So I was just trying to show you the skybox. Let me get rid of that model. It might crash if I open another. Yeah, I will fix that bug. I just don't have a day to waste fixing one bug for now. We're just loading. Let's get my laptop cooler on. So yeah, I just turned the laptop cooler on and I lost one of my screens. Too much power. Let me fix that. That's enough. Okay, so I've loaded the house. No, I loaded the wrong model. It's all going wrong. Okay, footage. There's an extra folder in, so the files all moved down. So I clicked the wrong one. I'm used to clicking in a certain place. Right, there we are. Fun facts. Hey, welcome back, man. Why haven't you hit like already? You're not listening. Actually, if you hit like, it brings more people into the chat. Gives me more, helps to build the channel. So this one, the sun color. Okay, yeah. So the sun color is acting upon the skybox. It's a pretty decent skybox, that. I quite like it. I'm doing good, thank you. I didn't answer your question. How are you? What was that? Project's going good. I managed to get some of the loading class implemented. Which means I can bring I can load some animations in star.fbx files. I'm not sure if tree works. Oh, so it does. And then we can see, so there's no animations available. Let me just bring this over here. I need to, yeah, no, we'll keep that over there. Got my big head's in the way. I wanted the cat in the camera, but she's going. 6. Sweet. How do I get the chat back? Okay, so that didn't work because there's no models in that one. So let's restart. No animations. Let's wolf with animations. Okay, so we've loaded up a wolf of animations, apparently. We get an error there. There's actually 6 files to that, so it might have been the wrong one. Okay, we have to go again. Star.fbx wolf. It's just loading. Okay, there we go. So here, this is what I wanted to show you and show me. But also, why didn't it come up here? So this is what I've implemented with the help of ChatGPT. And I could do with making that text bigger for the stream. But essentially, when you open a model, it checks if there is any animations associated with it, and starts to put them in some data structures. So animation is 24 ticks a second, 24 frames. Bone animations, there's 46 bone animations. Let's have a look. 46 bones. Wait, that was all. Okay. That was animation 1. Yeah, so this is animation 1. And I think all the animations it impacts. Rotation keys, position keys, scaling keys. But this is all your data. It's a lot of data for an animation. You think you're processing that across every vertex, every frame for one object? I'm going to be interested to see how this all works. Did you see the cat? Come on. I just knocked my phone and she just went crazy. Sweet. Okay, now let's see the wolf. I'm in the world. Nice. We need some light on it. It's too shiny. Where are they? Oh, you came back? Yeah. Is that the one? No. Yeah, you can see my engine's so messy. So what I do, and it does help me most of the time, when I load any object file, I load 5 and I put them in random locations, and that just helps with testing the lighting and the matrices being set up and the camera and everything. And I think this is the one here. Yeah. So this is a little wolf anyway. I don't know why it's flipped. I don't know why it's so shiny either. By the way, on your sliders on IMG UI, you can just control and click and it lets you type. Shouldn't be transparent. I think it's textured. But there's a wolf. And I think that is, these bad boys need to go. And I think it's the sunlight moving on it, yeah. Looks quite messy. I think it's the diffuse. Maybe black is what you need. And just start moving the sun across it. But that's your wolf. Also, we can inspect the object. So render, and then here. This is, let's have a look here. So this is a submesh viewer that I coded up. Move your camera a little. You can get it. Mesh. I'm definitely having some trouble with this wolf. So what it would do, it would just look at one part of the object at a time. So you can see this wolf is made from 5 different 1, 2, 3, 4, 5 different meshes. But in Blender, they've drawn the scene of the wolf, and then instead of the wolf being in the middle, they've just put him over there. So this zooms to the middle. So I'm moving the camera. So I'll put these tools at the bottom just in case things aren't rendered properly. But it's just a crap bit of Blender. Let me show you if I open up the cottage. There we go. So it just should be as simple as that. So what's it doing is the cottage is made up of, I don't know why, but the brick at the bottom, the blue thing, turquoise, the actual base, and then the cottage itself. So if we go across, have the brick, and across again. Maybe next, and next again, and then a base. So this lets you edit things, and you think, well, why do you want that? But if you have like a car, there's a car model, it's made of like 1,000 pieces, and so when you're looking at the model itself here, like you see the house, if you edit in the back window and you don't know which window it is, you just got to like orbit around, and it just takes a lot of time. But this will just let you go through the individual pieces. Of course, I need to zoom out a little. Let's pan the camera. That's neither of those, but I'm going to put a tool in to zoom out as well, so then we can see it all. Because this box is just too big. It's not really helping at the minute. The concept's there. Okay, so let's get rid of that. Just a little tool. I do enjoy my little tools. So now what we're going to do is ChatGPT, and where I left off earlier, let's get that over there. What I want to do is start, so that animation I've just shown you, the list of animations, we want to start importing those movements into the world, into the engine. So the first thing I want to do is refresh myself on the code, which is here. I'll make it a bit bigger, and bigger like that. One more time there. Okay, so how does this function work? We have a function called initialize all meshes. The scene object is, so when you import the wolf, all its data, how many vertices, how many triangles, how many textures, how many animations, how many bones, it's all in scene. And then you can call scene dot, and you have a list of member functions. I don't think you can see these, but for example, I'll bring that in. Animations, so that's, does it have animations or not, or how many? Let's have a look. If we hover over, You probably can't see the IntelliSense, but it says yeah, so I think this is how you get into the animations. So the animations are all stored there. But then there's has animations. And it will just return true or false on whether it has animations. And now we obviously know when we import something, but our engine doesn't know. So the engine, you can run that bit of code and ask, does this have animations? And then if it does, go to this bit of code. If it doesn't, go to this bit of code. Because if it does, you want to then say, what's the next question? And you say, well, how many animations? How many bones? Which bone affects which part of the character? And from there, you can start to create data structures like the arm and the head and link together how the bones move all the vertices. And so it's starting with this powerful function. Now, I've never done animations before. I am an animation noob. Red wine time. Okay, so next. So this is initialize all meshes. And what's the first function it calls? Actually, the first function is this one, initialize from scene, which is the scene pointer, and then we go to initialize all meshes. So the wolf might be made of 5 meshes: the head, the torso, the body, the front paws, the front legs, and the back legs. You thought I was going to say the arms, didn't you? So initialize all meshes. So whatever this function here does, it will go for every mesh. So we're in here, and then there's going to be something within the scene pointer that tells us how many meshes are a submesh. So let's have a look. So we take the scene pointer and we go to process node. Node might be like a component or a level, a link in the chain. So if we go in here, and then we go to, we've still got the scene object, and here we do a loop, which means we do an action a given amount of times. And how many times? How many is determined by the number of meshes. So this will give us the number of meshes in the animation. So head, torso, 4 legs, 5 times. And then what will it do 5 times? It will do this function 5 times. So it will initialize a single mesh 5 times. It's going for all the meshes. So this is the real function. The others are just layered to get to the to separate the data. And so it's doing like one thing at a time, functions. Initialize single mesh. And what we want is animations. And by the way, we've gone past it just in case you saw that and got excited. Well, we went past the animation section at least, which was the bones. Unordered map, bone mappings, and what have we got? Iterate over all bones in the mesh. So we're doing a loop based on the number of bones, and then what do we do? Bone name. So we take the bone and it has a name. Dot data, and data is a string, so it actually has a name, which will come from Blender. When you make an animation in Blender, it appears that you name it a leg or a head and so on. Then it's going through the map, which is the unordered map here, and it's saying if it doesn't already exist, then if it's not in there, then to put it in, basically. And then what do? We take that given bone, we loop for all its weights, and then what do? We take the vertex ID, assign bone to vertex, bone index and weight. So we're building up the vertices, which is, if we go here, so vertices new. A vertices has a position, normal and texture coordinates usually, but also we're giving it a bone ID and weights. So how much that bone affects a part of the animation. Okay. Initialize single mesh, assign bone to index. Loading is working. Let's build on this class. So I need ChatGPT to show me where I left off, rather than going through 1,000 lines. I left this a week ago. What else have we got? Bone. Load animations, yep. Okay, we need to update vertex positions based on the weighted influence of bones and their transformations. To be honest, I just need to see this in code. I'll understand it better. So what I need to do is provide my header. This is the current header, and that's spelled wrong. Wow, this is just so heavy. And let's see how that compares. Position key, rotation key, scaling key, bone animation. Animation data. It's pretty simple. You need a way to store and retrieve bone transformations in the bone hierarchy. For each bone, assimp will provide model name, node name. It's going to go down. And for the hierarchy, the scene provides a tree structure with nodes. You want to create a helper function to process the node hierarchy and apply transformations. Update bone transformation. I need to move that there and that can go there. Okay, so we make a string, find the bone animation data corresponding to this. So we pass in the current bone and the time and the parent transform. Interesting, so we're going to call this function many times, which is what it meant by the tree. And then we take bone animation. What is bone animation, by the way? That's part of our structure, which has the name, the position, rotations, and scale. So it has the full transformation. So the bone animation, we give it a name, and we find bone animation. What is that function? Find bone animation. Probably this helper function here. Okay, if bone anim, so that means if it finds something, interpolate position. So that's going to get the new position based on where it is in the frame. So how many frames for like how many seconds and so on. So there'll be keyframes, like the man will start here or the wolf, and then it starts moving its head. It ends up in this position. Interpolating is the movement of the head, all those frames in between, which you generate that data. Okay, I want to look at these functions here before I just code it out. Interpolate position. Okay. So before that, we calculate each bone's transformation by interpolating between keyframes based on the current time. So there's a frame here and there's a frame here, like it's moving its head. And then based on how many seconds have passed between we draw the first frame, it's, as I said, it's interpolating or filling in information that we don't have to move its head. Okay, we apply the parent bone's transformation to the current bone. I'm not sure what that means. I think it means if you've moved the head a little bit or the leg, it moves the torso based on how much you move the leg to save resources. We apply the parent bone's transformation to the current bone. For each bone, the resulting transformation matrix is stored. Interpolation functions. For each bone animation, we need to interpolate linear interpolation between keyframes for position, rotation, and scale. Why would the scale change? I don't know. I guess because muscle can stretch, things like that. So interpolate position. So does it take the parent bone animation? I don't know. So what I like to do is I like to go through the code and in my brain understand what it's probably doing. Read the theory, code it, and then you kind of see, and when you've learnt it, right? Now most things I will go through in the engine I already know a bit about. This is completely new, but it's good fun. Daniel, welcome. Cheers. Okay, frame index, find keyframe index. What are these find functions? Okay, I'm going to say to ChatGPT, let's create the find functions first, because those functions start off all the other functions. So then we need, even though they're kind of done last, we need to. It's the base that everything's built on. Okay, find keyframe index. Where's time? Animation time. Animation time. Ah, I missed this. Okay. So we're going with a new class here, animation controller. Okay, what we need to do. Data. A new class. Is this the first animation class, by the way? Yeah. Class. Animation controller. This is a bit too cold. Daniel, I recognize your name. You've been here a few times, right? Okay, animation controller. So this is the class. I remember when I watched, shout out Chili Noodle. I watched him doing some class before I knew about classes much, like a few years ago. And I was like, this is deep. Thought if I ever understand this, it would be really cool. But it's the bread and butter. It's the basics of C++ object-oriented programming. It's the basics of most languages. Okay, this is called a constructor. It's in the brackets. It has the same name as the class. And when you create, so we're defining an animation controller, but it doesn't mean we're creating one. We're just defining it, and then creating it is to put one in the program to use. So when you create an instance of an animation controller, it calls the constructor. So whatever you put in here is the first thing it will do. So you might set up some memory, you might set up some variables, you might import some animations. Yeah, that's about it, to be honest. Okay. Now it's a bit strange because I'm teaching on something that I've never done before, so I'm really just talking myself through it. Okay, so void, this means it is a function that doesn't give you any information afterwards. It just sends nothing, void. Everything it does is inside the function. It doesn't send anything back to you. So update, bone, transformations. Now I know most of you would just copy and paste all of this from ChatGPT, but this is how I learn. Update, burn, transformation. So here we're defining a function, and then here in the brackets we're going to tell this function what kind of information we're going to send to it. So if we're updating a bone's transformation, how it looks in the game. Now by the way, a bone is just a part of the model, the guy's hand or leg or the woman's leg, or the sword, the way the sword is facing, or the tree. That's a transformation. Where it is, which way it's facing, if it's been made bigger or smaller. So we would send it different information. Float is a number. We'll send it the current time, because as time passes, the animation's moved. So you need to know the time to see where it's moved in the animation. Okay. Then we will send. This is going to be the bone itself, I think. Now when something's constant, it means when you send the information or the data to the function, you can't change it. It's protecting it. Like you might want to not be able to change what it looks like, so you send it as constant. So you can read the information and maybe draw it to the world, but you can't change it. So it's a way to protect the information. Okay, constant AI, which is asymp AI matrix 4x4. I've never seen one of those, but it's going to be a transform, parent transform. Okay, I won't talk through all of these, but just for some people it'll be good to hear and see some of this, because then you'll be like, oh, I think I could probably understand this if I look into it. Okay, what have we got here? Constant. Somebody's washing machine. Somebody. Right, Where did I go? I don't even know what day it is. Okay, now this is going to be another function, as you can see from ChatGPT, called find burn animation. So this is what we want to know. So it's going to return, instead of void, it's going to return a burn animation. The function is called find burn animation. And this is a really good way to learn you need to know the basics and the intermediate of C++ to be doing this. But it's a good way to learn sort of as you're getting the cheats from ChatGPT. Just go through it all, read every line, put it into practice, and if it's something that you're going to use over and over and over again, then make sure you know exactly how it's working. If not, it don't matter, because if you're writing 100,000 lines of code, you just need to know how 95% works. So these are underlined in green because it's saying like what is this function? All you've done is given it a name. There's no how does the function work. So it's saying you haven't finished this function, which you do in the C++ file. This is the .h. This is the header file. This is the header file. So it's underlined green. It's not an error. It's just a caution saying you need to finish this. Okay, these are called helper functions. Usually give you very small, give you a bit of data. Functions to interpolate between keyframes. Okay, I'll copy and paste these for speed, but I have to write them out again and finish them. And when I do that, later on, I'll be typing them in full. Okay. Templates, I'm quite weak on templates, to be honest. 1 second. Okay. And why is it templated? A template function just gives you flexibility in the type of information you send to it, because you might need to use it you might need to use a function in a different way each time. So you tell C++, so template, type name, and then key type here. I think this word, whatever word you put here, becomes the adaptable bit of data. You'll see. Find keyframe index. Find keyframe indexed, float animation time, a constant, we send in a vector, which is like a collection, a vector of key type, so that's the data structure that will change. Now private, store the final transformation, store final transforms for each bone. I can do typos. We're not afraid of typos. So if something's private, it means you can't access it in other folders outside of the class, but your functions here can access it. But you can create other classes called a friend class that have certain permissions to. So why would you do this? This is when you got more than one person working on a project and you don't want them messing up your code, basically, or you don't want yourself messing up the code. Okay, that's the header. Hey, I'm good, thank you. I'm good. Back in Jeb. Welcome back. I hope you hit like, by the way. Oh, my back. I'm on my second glass of wine, but they're kind of like, they're not really been full glasses. Okay, let's continue. Given a bone name, this method will find the corresponding animation data for that bone. These functions interpolate. Find bone animation. So what we do here, I'll go to the function. So if you click it here, find bone animation, press Control and full stop. Now you can't see the pop-up, but it will come on my screen saying create definition. You click that, and then it will take you to, it will give you an outline of the definition, and then we can start to code it. Okay, this is a nested for loop. What happened there? There we go. So everything within these brackets is the function. The 2 lines means it's a comment, so it's not any code. This is the function. So now we're going to make it do stuff. So for is how you start a loop. It's called a for loop. Auto is not relevant right now, although most of you will know that, what it does. Okay, so this is a loop, and what we're going to do, we're going to go through every one of our animations. So if there's 10, it means we're going to do whatever code is in here 10 times. That's a for loop. And then within our collection of animations, 10 of them, we're going to go for each one, and it will give each one a name. We can say like Annie. So then every time we use Annie, it's doing something on each individual animation. But of course, it makes sense to call it an animation. And then we're doing another loop. So this is called a nested loop. So we're going through all 10 animations. We're just saying 10, right? And imagine within each animation there's bones. Bone anim. So then what we're doing is, where it's animation in yellow, we're accessing that animation. We're accessing its bone animations. So we go through a collection of 10 animations, we extract each individual animation, and then through that individual animation we do another loop, and then we say, is this bone anim? Is this particular bone of the particular animation? Is its name? Now this is the name we're looking for. So is its name the same as the name we're looking for, which is the one we passed to the function? So it might be called leg. So we go for all 10 animations, then we go for all 10 bones within the 10 animations, so 100. That's why we have 2 loops. And we say, is bone 97 called leg? So that's how you loop for 100 bones. And this is really abstract. And then if it is, then what you do, you say return, which means give back to the program the bone anim. So if that one's got the same name as the one we're looking for, we tell the processor, we give it that, we say this is what you're looking for, and then it ends. Return means it ends. And here it tells you here, this function, animation find bone function, when it finishes it sends back a bone animation, which is what it's doing here. Again, if you don't know much about this, you're only going to understand a little bit of that, and if you know a bit about it, it's wasted time for you. Yeah, feel, I saw those typos. Okay, where are we? Let's keep going. I should try and do a Tokyo Spliff run, like a 5-hour session. I think I've done one 5-hour before. This is 1 hour, maybe not. Okay, code, ChatGPT. And then, so if it doesn't find it, by the way, it just loops again. It loops for all the bones in every animation. And then if it doesn't find it, it doesn't return. So it comes to this part here. And then we return something called a null pointer, which is like a reference to nothing. Like we send it empty. Then in the other part of code will be like, oh, you sent me empty, and then it knows what to do. And that is spelled wrong. Animation controller. I must have pressed something there. Okay. And then what I want to do, I'm going to copy and paste. And I've just copied and pasted it from ChatGPT, just in case I did a typo. I didn't, because it would have said, but I don't want to risk it. It's the same. Otherwise, I'll try to run it later and there'll be an error and it'll take me 2 hours to find. No. Okay, so that was find bone animation. I think there's another find. So let's do find keyframe. So we go to keyframe, control and period, and then click create definition. You can't see that. And here we go, it's a template function. And we don't need the return thing. Okay. Okay, I just sent a post in another group saying if anyone wants to learn to code, come to this channel, so they might come and get annoyed. Shout out. Okay, find keyframe. So for unsigned integer, an integer is a number. An unsigned means above -1, so 0 or above. So we're doing a loop here that starts at 0. So we're counting this loop. It's a different type of loop, and the loop will go through. It will be dependent upon how many keys there are. So if the size of keys is 5 keyframes, it will loop 5 times. Then -1, so 4 times. Presumably it doesn't need to go to the last frame. I'm not really sure. And then we say, so this is to find the keyframe index. So what this is going to do, if you have an animation where you're loading a gun, or let's just say an animation where you're running, there's going to be like keyframes, so your arms here, then your arms here. That's just 2 keyframes. All the frames in between, they're generated based on the starting and the last one. You don't draw those in animation, so that's why you have keyframes. The rest are interpolated. And so what this is doing is it's going to get the time that the animation's been running, so maybe 1.5 seconds or 0.5 seconds. And if the full animation is 1 second long, 0.5 seconds would put it between the first and the last frame. So it wants to know whereabouts it is within the how much time has passed, so then it will know which 2 keyframes it's in between, and then it will draw appropriately. So it's going to say if animation, nope, it's not going to. It's going to say if animation time is less than keys, this loop. So it's going through the first key. So if the animation time is less than a given key, dot time. So it's checking how long the animation's been going. It's checking a given key, a key frame, and if it's less than that, it means it's on this. This is the key frame that it's on. So you know where you are in the animation. Now this needs to be taught visually. So when animations are working, maybe we can make it so the animations change color on keyframes, so you know what's happening. You need the code and you need the visual. I've never animated before. I think I've animated in Blender. I think I've made an animation or 2. I've never coded one, so I'm just kind of telling myself what I think's happening, and the comments from ChatGPT are filling in the blanks. By the way, if you're just joining, feel free to hit like, subscribe. Also, if anybody knows of a free, so you can search this now on YouTube, copyright free music, and if anybody wants me to play some different music, as long as the title has copyright free in, then I'll run it through. This is just playing some cozy music, but I'm up for changing the vibe. You can search it. But also, if you don't care, I don't care. We're all good. Okay, back to coding. I've lost one of my screens, so I'm a bit slow. How did I lose it? What did I turn on? I turned on my laptop cooler. Vector GLM map 4. Is that an error? Yeah, so here I think it says an error because I'm using a file that I've not told it about. GLM. Maybe it's this one, I think. Yes. And then that error should disappear, maybe. Yeah. So GLM is like a maths library that has a transformation. So that's a 4x4 grid. So that's linear algebra. If you're asking yourself what maths do I need for game programming, linear algebra. doing now. Okay, bear with me. And what was we working on? So we did find keyframe. Now we will go back up to, oh, this is a big function. So find bone animations, update bone transformations. Okay, that's your main function. So control and full stop. You can't see it on your screen, but create definition. So this will bring us here to the function. Actually, I do think that the return. Wait, find bone animation. Didn't I just fill out? Find, what was it for find? Find keyframe index. So where did that go? Find keyframe index. Why did it put the function? I think because of a template, it's put the function in the wrong. It doesn't matter. It doesn't matter. Just put it somewhere else. Oh, that's okay. Update bone transformation. So here we go. So it's going to get the name of the bone, interpolate position, interpolate rotation, interpolate scaling. No, let's do those first. Interpolate position. So interpolate position, control and full stop, and then it will let you click create. So what I'm going to do is, I think I'll go through them actually and get your money's worth. So the first thing it's saying is if bone animation positions is size 1. So what's this? Okay, this makes sense. If there's only one position of the bone, we just return the position. We don't need to find it. If there's more positions, so interpolate position. So the starting position of your arm, the ending position of your arm, and the 2 keyframes. The interpolate function is going to draw all the steps in between. So that's what this will be doing here. It will need the time, the animation time, and the current bone. It will find the keyframe index, which is what we just coded. It's quite, I don't know if I want to say it's complicated, but so for this you need, if you didn't have ChatGPT, so 2 years ago you would need, you'd be using Blender, you'd have your animation book out or a tutorial online. But I think just the documents for assimp, so assimp is the program that imports animations to your program or the game engine. But I'm just asking myself, how would I do this without ChatGPT? It's just so layered. But I don't want to say it's hard. I think you just need a day or two building the class up, understanding everything, following the flow, and then it's very logical, like all logic, like all code. Okay, so what we're doing here, we're saying if bone animation, by the way, that's this here, that's something we're passing to the function. So we're saying if the bone animation positions, the size, in other words, the amount of positions equals, so you don't have 1 equals in code and you have 2, it means if it's equal to, it's checking something. This means that this is telling it how many it should equal 1. 2 is checking how many. Is it equal to 1? If it is equal to 1, you create the curly brackets and it will do whatever code you put in here. So you could say exit and it would exit the program. You'd put return 0 or something along those lines. So you'd say return bone animation dot position. 0 means you haven't gone along in memory any spaces, so it's the current position, so it's the first position even though it's a 0. And then position has something called a value. The dot allows you to access, so if you did position 1, which doesn't exist, but we can still choose its value. Because the program, even though we know it doesn't exist, the C++ doesn't know that. So you can create errors in your code. Free messages. I've just got a message from, I think, friends in 2 different countries. Okay. So the data in red, and the lines in red here is information. This is variables we're creating, so it's something in memory that allows us to save data. So unsigned integer means a number, so this is going to be a number above -1. So a normal integer int can be any number, -1,000 plus 1,000 up to like 620,000 or something. And if you want a number even higher, you call it a double, or I think there's a double for it, like, oh no, it's called there's double long, there's like long, I think there's even wide, I don't know, and that's like multi-millions, even trillions. So we're creating a number called unsigned int, so a number higher than 0. Now it's going to be the frame index, so what part of the animation, which is it the first frame or the second frame, which is why it's unsigned. If it's pages in a book, or if it's parts in an animation, it's not going to be minus. It's not -5 animation or -10 page in a book. It doesn't make sense. If it was maths, you could have a minus. So frame index equals find key. Okay, so frame index, so the number we're going to give it, where does that number come from? It comes from the animation find, it comes from the function we just created, find keyframe. So we're going to call the function we've created now, we're going to send it the animation time, so how long the animation has been moving, and we're going to send it a particular bone animation with all its positions. So this means we're calling on a function, let's spell things right, animation. So we're calling on the function find keyframe index, and we're sending it the time, and we're sending it positions. So if I send a function every position in a given animation, so moving your arm from the start to the finish, and I send it a time, I say this animation is 3 seconds, it's been 3 seconds going, and then the function we've already written will say which of these positions should I draw to the screen when there's been 3 seconds of animation. It will interpolate, it will know that, it will know which frame that will be. Okay. So this is why I put cozy music on today, because it's a slow vibe. But please hit subscribe. We're normally going a bit faster. And we're normally doing some code that a subject I'm familiar with. This is just a brand new subject for me. Yeah, it's a brand new subject for me. So I'm teaching myself really. Okay, so what's going on here? Frame index +1. Okay, this is pretty simple. So we're creating something called the next frame, which is whatever frame index we're on, you just add 1 to it and that's the next frame. So presumably later on we need to know the current frame and the frame we're on. So that we've created those two numbers. Now double is a long number, but I think it's floating point, which means with a decimal place in. So 1.5 or 1.3568. So delta time, so time is going to have a point in, like 1.01 seconds. So I have smooth animations when it's just moving a little. So this time equals bone animation position, next frame index. The time of that bone animation. This is going to subtract 1 from the other. Frame index. Let's have a look. This one here, basically. Dot time. If you're just joining, we're just putting some code together for the engine. What I'm going to do now, maybe for 5 minutes, is just make sure everything's working and then load up the engine and just see a bit of what we're creating. Nice, we've got some errors. Key.size, key, should be, I think maybe an S, key, animation controller, find keyframe index. Let's have a look. Yeah. It's a reference to this. Nice, a nice linker error. One or more multiples, define symbols. Find keyframe index. Maybe. Find keyframe index. What was the symbol multiplied, by the way? No, cat, chill out. This cat's crazy. Animations, animation data. So it thinks I've already defined that, which I probably haven't. Cat, calm down, bro. Calm down, I'm on the live stream. Do you want to say hi? Stop it. Relax. What? So, but FYI, we're currently in a war zone. And we got bombed a few hours ago, and the cat's like high on anxiety right now. Aren't you, bro? Want some red wine? No. Right, you gotta go. Ciao. Okay. So this normally means this error. Can you see this error on the screen, by the way? I don't know if you've got it there. No. No, cat. Come on, bro. You're making me look like the bad guy. Say hi to the stream. It's the redhead. No. Dan, if you're watching, I love your cats. Okay. It's the struct animation do. Animations, which is where the I might have a variable with the same name twice in code. So we just got to search. This will be fixed easily. It's not that one. Where is this? This file is. Let's have a look at that. Animations. I don't know why, but I enjoy errors lately. I enjoy getting to the bottom of those. Okay, so what we need is to make sure we've got. Is it this function? Animation control. I don't think it's this, but I've never instantiated a template before. No, it's not that. It tells me here what it is, but I just can't work it out. So I'm gonna ask ChatGPT. Which function or structure is it referencing? Where was that? Find keyframe index. Position key. First off, I missed that, but that's not the problem. But it's interesting that it does seem to be the template. Ah yeah, it tells us here, position key. You can't see that here. I was looking at the top. Position key. Unresolved symbol. Okay, so I think it does need to be in the header. because it's a template. And then we do that. I wonder if I can I might just be able to put it here. And if we do that, I don't know. Nope. And one was private, one was public. Is it that? Nope. Ah. Also that. Member function already defined or declared. Define keyframes. So interesting. Okay, ChatGPT already declared, it says, of the templated. Some of you watching know what this is. I just don't. I've not played with templates ever, except on shaders for sending uniforms. I already checked that one. I thought maybe there was more than one animation type. Okay. To properly declare and define a templated function. So if you don't know, because I'm wasting your time a little bit, I've got a few screens going on, but a templated function is, so your function is something, a bit of code that will do something, of course, and it does it in a very set way. But if you need more, like for example, you might add two integers together. So you might have to send a function to integers, so you'd send, which is a number without a decimal place, so 5 and 10. So you'd send an integer, 5 and 10, you'd get 15. Now then, if you wanted to make another function that handled floats, so 5.5, not an integer, and 6.53, then you'd write another function to deal with not integers but floats, floating point numbers. But these functions are almost identical. You're writing it twice. So a templated function would let you send either integers or floating point numbers, but the Visual Studio, the code doesn't have to know at compile time what you're going to send. So once the program's running, it doesn't know what you're going to send, but it will still work. And I've not dealt with these functions that much. They're quite simple. but I've just not needed them. Where are we? And so I'm just saying to ChatGPT, why is this not working? Templates need to be fully visible to all translation units that use them. Put in the definition in a C++ file would result in a linker error. So when you do one of these functions, you can't put them in a normal C++ file. It has to be in the header file, which is normally a small file. I didn't know that. Probably 3 years ago I knew that when I last did it. But now the only problem is, and this is a problem, what I've done is, I think, right. So I think I've already done it in the right way anyway. So now I don't know how to fix it. But I do know how to find out how to fix it. Come on, Homer. I've got 6 people watching. Help me. One or more multiply defined symbols found. So I think it's now the animations. This seems to be already somewhere. The cat's just trying to sneak on. She sneaks like she's hunting, but just to sit on your lap. It's like, I'm gonna see you. Okay, so I think we have a different error now. I think I have this animation here. I think we have this somewhere else of the same name. And code doesn't like you to use the same name in the same scope. But the problem is I searched for it earlier, right? Oh, I only searched open documents. I need to search all documents. And it's called animations. So what we're going to do, we're going to do animations new. Because if I find it somewhere else, presumably the one that I find I still need, right? So just finding it somewhere isn't going to fix it. So I need to just change the name of this one. So wherever we see animations, that might be the only place, to be honest. So that, apparently that should fix it, in theory. And then, as I said 20 minutes ago, I'm going to show you the engine. And this is why if you type in loads of code, you should just make sure it works halfway through. Okay. So engine is running. Let me do that and that. And that. And so shout out to the skybox. And maybe I should remove that writing from like an hour ago, 2 hours ago. Can you see the cat on camera, by the way? I know she's going to try and jump on again. That's not an invitation. It's a little bit cold here. I'll turn the aircon off. Turn the aircon off. Okay. So what have we got? We have got an engine. And what can we do? Let's load up some terrain. So let's have a little look at the engine. I know for some of you guys, if you're like me, if you just see too much code and you're like, but what are you building, bro? Like, what are we doing here? So this is from Perlin. This is Perlin, no, not Perlin noise, but it's kind of like Perlin noise. This is procedural terrain generation. So there's functions that just generate random numbers. Let's say 1, 5, 7, 8, and then it will draw terrain based on those values. So this, it will be like 1 high, then it will be 5 high, then 8 high, then 2, and then that's how you generate landscape. Now, if you throw out random numbers, it's just going to look like imagine the skyline in New York City. It's just going to be like this, and then really high, then really low. So there's algorithms, noise algorithms. It's called noise like random, but there's a beauty and a pattern to it. So instead of throwing out random numbers, it will throw out numbers that are close to each other. So then it's smooth, and then you can call it terrain. So noise generation is used for all sorts of things, even sounds. And if you look at the mountains, and I'll do this, you see that they are. So these are all the different numbers that have been generated, and then we tell OpenGL and C++ to draw triangles and draw those lines together based on those numbers at height points. And then we say we find a texture from Google of mud or grass, and then we say cover those triangles with mud. And then you're gonna say what's all this coloured stuff in between here. So this is now where we get to the engine. If we load in a file here, so let's say rock.jpg, we're going to import a file from earlier and load it at different heights. You're going to see it. So now that is just, I just grabbed a free file, it's just for a demo, right? So now this is your rocks, and we can change that angle where it blends. It's mixing rock based on how steep or flat the ground is. And we've got a grid here. The grid is just to help me with positioning things, but that's not part of the world or the game. We can hide the grid, and you can appreciate some pretty water. The water is just reflecting everything around it, and it's also slightly transparent, so you can see what would be underneath. And then we have sun color, so we could say it's a purple sun. So now all of the terrain, the texture we just spoke about, is slightly purple. All of the sky is slightly purple, and the water is slightly purple. By the way, the water looks like it's moving when I move the mouse. That's just in debug mode. That's just for me. It's just it's a little bug that it's not important. What else? We can say how bright is the sun, so we make that purple light impact more. It's just maths. But really you'd want a light blue, very light blue. And you've got a sky. You change the position of the light from the sun, and you've got a day and night cycle. You add more detail to the noise that we generate. If we zoom in, we're going to see when I press export. If you look at the terrain, it's going to give you more detail. There you go. And if I take that out, go backward, less detail. And then somewhere in between. And then kind of the highest amount, boom. And then you can say much more frequent on the hill. So this is making the noise very wild. Let's go again, double it, even more. Let's treble it. This is just going to not look good, but you might have some rock scenes like that. So this is giving me Skyrim vibes. Obviously, for Skyrim though, you'd say a bit of rock, and then you would say. And by the way, this is just a test texture loading. Now, I wouldn't recommend these textures unless you're making a huge world, because they're quite low quality. And you'd load a bit of snow, so now we have snow. And then I think I have some code still that just blends it a little bit. And it's not really great, but it gives you an idea. Let's take some of that noise down so it's not as jagged. Still too much. Boom. And then you change the angle where it's drawing. There you go. And this, you can see some strange lines in here where the new levels start. I think they're defined with these lines here. So you could have snow, you could have snow 2, and then what might you have at the top, or just at the bottom you might have a bit of grass. Okay, so let me show you. Let's clear the textures. So your first texture might be grass.jpg. Now these are all things I've grabbed off the internet a while ago. So there's your grass. Now you want your grass to end there. And then, actually you don't want grass, I'm lying. You don't want grass. Okay, I'm going to tell you what you want. Sorry that I've ignored chat. I don't know if anybody's there, I'll come back. You want some sand. Okay, you want some sand. And then you want some grass. That's a lot of grass, right? And I think it's probably there you want it. And then you want rock. Now, by the way, this is just doing it with the interface. But once you've made a game world, you wouldn't do all this every time. This is just to test the engine, really. What we've got here. So there's some sand which you can't see right now. It's under the water. But if you go elsewhere in the world where there's no water, you will see it. So sand, then grass, then rock. And then you would have snow. And then you blend. So it's not perfect, but it is working, and it's not bad. Shout out chat, anyone around? No one around. But let's be honest, if you're making a game like, I don't know, an old style sort of Command and Conquer, or a game where you're God, you throw a few trees on there, get some higher quality textures, just bump it up a little bit to the next level. You can pass this off, I would say. You need your light, you want to get your lighting better. Get your effects in. But it's just very bare bones. You'd import some trees, get some lights on the scene. It might crash now, let's have a little look. I've got a texture here that's a bit messy. Every time I load it, it crashes. A model. Okay, so what I've done here, let's have a look with Y, with Z. Okay, so these trees don't belong in this world, like they don't match. But you can just start to position a few things around, and also I think the lights will now work. Let's say an orange light. I'm pretty sure those lights should be animating my scene. By the way, if you was here when we was doing the animation, I don't know if this, I think this might crash now, yeah. I've just got a little bug in when I load. But if we open, I don't think you can see the open dialog because I'm not sharing the full screen. But if I open the wolf, it's loading up. Where's the little homie gone? I love it when my little boxes disappear. Come to debugging. Star.fbx. I don't know if that worked or not. Okay, that's done it. Right, first let's find one of the wolves. It's loaded 5. So I load 5 just so I can have a bit of variety and test the lights and test everything's loading. I could just load 1 in the middle so I don't have to look for it. Okay, so what it's done here, so with our code, it's given us, I wanted some information. So now I'm trying to get animations in the program, and there's going to be 100 errors, right, over the next week or two. So the first thing I've learned, the first thing you want to do is put data on the screen. Instead of Visual Studio just crashing and saying there's an error and it's error 5689, you don't know what's going on. What we're doing is we're gonna load a file, and it's saying here, I don't know if you can see, total animations is 36. Is my microphone still working? Yeah, shout out the microphone. It's probably too loud, knowing me. Okay, so it's saying this is animation 1, there's 36 animations in total. It's the speed of the animations, but if we go through here, this is all the data in the FBX file. But what this means is that the engine has loaded everything. It's all there. So for example, animation 11 is 10 seconds long. Now I've got to guess most of the animations will be similar lengths. If you're moving an arm, the other arm or the other leg, even if it doesn't move, it's still active for the same amount of time. I don't know, I could be wrong. Some animations are 40 or not seconds but units. Another is only active for 1 second. I'm interested to see how that works. I know what that will be actually. What that will be is it won't be just because it's walking. Maybe there's an animation where it just growls. So then its mouth's moving, the rest of the body's not moving. So there's different, like you move your character to the left, to the right, it can jump. These are different animations. This is why I put all this on the screen. This didn't come from ChatGPT. It's like I want this visualized. Okay, hit shift again and it brings up, that's a good little trick there, interface hack, just to hide everything. And let's see if it's going to load. Do you know how impaired, one of my screens has died and I feel like it's so restricted? Because that's the streaming screen with all the streaming tools on to change what I can see, what you can see. but it is what it is. Okay, so I've just loaded up the car. Now, if I go to the top, it's going to tell us how many animations are in the car. I'm guessing it's 0. 36. Yeah, it looks like it doesn't. When you change to something without animations, it doesn't update, which just means I haven't coded that. If I go to the Bugatti, just show more of that engine. Here, for those that didn't see. So this tool here, I've called it a submesh FBO render, right? We're going to change the name. But if I put that over there, and we go to one of the cars, let's see which car we want to go to. I didn't help out, it's that one there, I think. Here. So if we wanted to, so normally this would be in the center of the screen. I've just coded it a bit strange. But if we wanted to start to edit this car, so the car is actually made up of, I think, 70 different meshes. Now you wouldn't really edit much in the engine, you'd edit it in Blender. But sometimes when you import something from Blender it doesn't work, so you want to just inspect it in the engine. So you can either just look at all the parts here, the car, and then start to change colours and different things in the car. But when there's this many parts to the car, by the way, I'm really liking this because I don't know what I changed, but the names weren't there before. So I don't know, my engine just woke up. The fuel tank name is there, the mirrors. So if you click it, now what it would do, if I press render selected submesh, the thing I click will render, it draws it here in the engine, but it also draws it in our window here. Now this shouldn't be so big, but for now I need it to be big. And this is what we clicked, the mirrors. So this is the mirrors on the car. Now if I make those transparent, they disappear. Now they also disappear in the car, but I'm guessing it's the mirrors, the wing mirrors? Yeah, you see the wing mirrors disappearing here. So I created this little tool here so we can inspect one part at a time basically, because you just wouldn't know, like, yeah, on a car you know what a mirror is, but on a mansion with like 10,000 pieces you wouldn't necessarily know. And if you press next here, it would just go through to the next thing, and the next, and so on. But what I want to show you, if we keep going, the wheels, whatever. Now this probably took 2 days to get this bit of code right, but it's just going to save you so much time. Okay, and this is the plane, so that's I guess that's a bit of body work. If we make it transparent, you can see, so now you know what it's affecting. And look, we're basically painting. You're painting your material. So this is the material information. We can change the level of shininess. I think when you have 0 shiny, the shader doesn't know how to handle that, so it goes white. You can make it partially transparent. You can see through the car. But why I did all this and added it to the engine was there's so many different model types like 3D Studio Max, Blender, FBX, BDS for Blender, I don't know, OBJ, there's like an M5 and Maya and all of those. They're all slightly different, so when you import it there's always something wrong. You might draw a house, you import it, and maybe the windows aren't transparent. So then you could take hours working out why. So I just created these tools, so if there's any little errors I can at least see what's wrong, which part's wrong, then go back to Blender and fix it. So this is me saving time, hopefully in the future. Okay, what else? I've got some lights in the scene. So if we have some lights, and these lights are not directional, No, they are directional, but I'm changing them to moving lights. So now if we spin around, let's hide this tool and everything else. So we should have some lights spinning around somewhere. Let's have a look. 2 orbs, there we go. And as they get nearer to the car or the trees, they impact things more. Let's add another 20 lights to the scene. They're all green. There you go. Now that's the light source, but in the real game you might hide the source. You don't need the sun, you just need the effects of the sun. So this button will turn them on and off, but the lights still work. So anything that passes through them, the cars, etc., they'll be lit up completely. See the car's changing colour? If I remove the lights, the car is getting less turquoise. Let's put some purple lights in the scene. Now you got to remember the way lighting works, it mixes. So those purple lights are mixing with the colours of the car already. So purple on blue, blue's already like similar to purple. With the red add blue. And the transparent part obviously impacts different. The wheels less. Now if you have no colour at all, it will just light up completely purple, because the purple has full dominance. And then what I'd maybe want to do at some point is, if I've changed some materials, I want to save it, because if I load this car again, it's going to go back to the defaults. Okay, my homie chat GPT. Where did we leave off? Update bone transformations. So this was the main one. This was the first function, if you was here earlier. I think what I'll do is, I'll just go straight to the code for you guys. And feel free to join in the chat. Feel free to suggest new music. As long as it's copyright free on the YouTube page, and I'll stream it. So this was the first function, but the reason we did it last is because it depends on, it calls on 3, 4, 5, no, 3, 4, it calls on 4 other functions. So we created the 4 other functions first. So the first thing we're doing is making a string. If you don't know, a string is something that will store a word basically, so like leg bone, okay? So we're creating a string, a variable, which is a data type called a string. We're going to give it a name, node name, and this is, I guess, the constructor. This will initialize and start off node name. So what will it be called? And we don't know what it will be called, but we can find out. What we do is we grab the node, which is the AI node, bone transformations. What is the node? We need Acon. I think it's the part of the scene that we're traversing. So we're going through like a tree of different bones. AI node. So I think within node there could be a bone. So what we do is we take node, and then it's a pointer, so which means you use a point here, and it allows you to get something from it. So we get the name, and then within name we have either the length of the name or the actual data. So we get its name basically. So this might be like the leg node, which will have maybe the bones and the vertices of the leg, the animations, the time of the leg. I think this is how it's been structured. And we reference it with node name. And then I'll borrow the comment from ChatGPT. Find the bone animation data corresponding to this node. So constant means that we're going to have some data that we can't change, so it protects it. We don't want to change the bone structure, we just want to retrieve it. So we're creating a bone animation, and this star means a pointer. So we directly access it where it is in memory. We don't create a copy. Find bone. So this is the function we made earlier. So we take the node name, we send it to the purple function. We know it's a function because it's got the brackets. It means we're sending something to it. If we press Control and click, it would take us to the function. It's just here anyway. It's sending it to this function. So we send the bone name to this function, and then we go through all of our animations, and we say which one of our bones in the animation has the same name as this one. And when we find it, we send it back. So basically we take the name, and then we find the bone that matches the name. So now we're dealing with not just the scene that has the bones and the animations of the time, but we've got the actual bone within memory. If you understand none of this before now, you'll only understand a little bit. If you understand a lot of this before now, then maybe you're sort of following along. But it's quite a big code base animation, so you just need to get it in and see it working, because you're going to get so many errors that you're going to learn what it all does anyway, because you've got to fix your errors. Well, that's how it works. That's coding. Okay, a transform is always a matrix, a 4x4 grid. It will store data. It will store, so this is like the bone, so it will store its location. So in the whole game world, is it stored in the center of the world? Is it stored down there in somebody's house? Like, where is this object stored? So its location, its rotation, so which way is it facing, its scale, so if it's been made bigger or smaller, and then what's the other one? I don't know. So translation, rotation, scale. There's something else. There's something else. That might be it. We can come back to that. Welcome back. Hi. Just got a message. Mode and transformation. So what this is, the way it works with asymp. So this is us loading a file, right? We're in the engine. We click File, Open. We load up the animation of the warrior. Okay, the main female warrior, and then she has multiple nodes that correspond to animation. And one of those nodes is the transform, the position, the scale, the rotation. So we go to the node and then we use the pointer and we say give us a transformation, and then we assign it to the transformation. So we're taking everything out of the file in Windows and we're putting it in our engine, and it belongs to node transform. Now we have that now. We can move it around the world, but it belongs to the engine. It belongs to the game. We're loading data. Transformation, that's that. Apply, and just remember this is quite a lot for animation, but it's a day's work. This is 1 day's work and it's in your engine forever, and that's it. Then the fun part is when you see things animating and then you bind some keys to it, so you press WASD or the control pad, it's just as easy, and then your animation starts walking around. You make it press a button and then it starts shooting something and it collides, and all of a sudden you've got some game mechanics and you can start to build. So this is just foundations. Apply the transformation from the animation if present. Okay, so this is real animation. Cool duck. Yo, cool duck. Hit subscribe already. Welcome. Cool duck. Have you been here before? I think you have, but I could be wrong. Wait, what's your drink tonight? Never drink more than half a bottle of wine. What is the general idea of the game all about? Actually, it's really interesting that everybody asks that question. So there's a game called Sapiens, which is, my voice is going to go on this stream potentially. Ancient mankind. So you're the deity, you're the superpower, you're the divine, you're God, you're the commander. And a game you've seen 1,000 times. You've got your ancient world, you've got your little people, and you're setting them off to go and build society. But it's a game that I don't want to put combat in until the game's finished. I feel that if I don't introduce combat until the end, then it's going to force me to be original and make the game interesting before there's combat. But basically you're building a society or a system. But that's all I know. Right now I'm going to have fun for a year building that engine. Hopefully. Okay. Let me code, bro. Shout out, cool duck. Okay. So we're going to say is it present? So there's a little error test, which was here. If it's not, null pointer. If it's loaded some data. Then we're going to start to create some translations of the looks of it. So for those joining, 80% of people don't chat looking at my statistics, but people are still here. So if you just join in, this is animation, and it's my first time through animation. Animation time. Did I type that wrong in the... Yeah. Animation time. So we need to send time of animation and also pass in the dereferenced bone animation. So it's actual data. So that's a vector 3D. So if this is to get the position and to move the position, so imagine, why is it a three-dimensional vector? So X, like on the school grids and the college grids, X going across, it would have been Y going up or down, but because it's 3D, also Z back and forth. So 3 components, three-dimensional vector. That's your translation. Now quaternion, which is like, I think it's some angles. It's not an angle, but it translates to an angle. Interpolate rotation. How does it know that one? Animation time, and we're just sending the bone. So we're sending a bit of data, the time, and it will give us back some angle information. Vector 3D scale. Sweet. Okay. Translation matrix 4x4. What's the T? 4x4 T. So this seems to be a function we're calling from asymp, and the function takes your translation. So the current translation, which is only 3 dimensions, and it'll put those 3 dimensions into a 4-dimension matrix, which is what you need to send to the shaders and so on, which would be like ultimately your view matrix. And we need rotation matrix. Let's have a look here, matrix 4x4. So rotation, that's interesting. So the quaternion has a function to get the matrix. Is it in here somewhere? So this is yeah, here. This is asymp code, so this is the library we're using. So it's not my code. This is everybody's using this. So we have the 4x4 translation matrix, then we have the rotation matrix, which yeah, this comes from a member function built into AI matrix. And then what we got? feel free to link us, man, if you've got something to show. So a scaling matrix. So a scaling matrix would allow the data to scale your model. So if your model's twice the size, it would make it every part twice the size, basically. This semicolon, a semicolon just ends the line. It means it's that's complete. Scaling matrix, AI matrix, 4x4. So this is something called namespacing. So within the world of AI matrix 4x4, there's like there's parentheses in the code, and then there'll be like functions and other commands and things you can access. So when I press these two, something comes up on my screen you can't see, and it gives me choices. Scaling is one of them, and then we would take the scale here. So this is a function that needs the scale 3D vector and the scaling matrix we just made, and it applies the scale to the scaling matrix to the scale. So now this scaling matrix has this data inside it, and then node transform. So we've created 3 matrices, I believe. Let's have a look. The translation matrix. So it's like a grid. The rotation matrix and the scaling matrix, and these affect all of the coordinates of all the vertices. So it positions things in the world, it faces things in the world with rotation, and it scales those. And then all of that needs to combine into one 4x4 matrix. All that data has to interact. Excuse me, I'm talking too much. Product. So then what we do is, so we made before node transform. So this is a transformation, and we say it equals. So we have these 3 matrices now. Translation matrix. So this is linear algebra. Rotation matrix, and multiplied by scaling matrix. So these grids, the numbers in a 4x4 grid, 3 of them will multiply, basically. And so the way it's facing, where it is in the world, and its scale will now all be combined into the node transform. And how that worked was it went through these different functions, and it took the time of the animation. So then it was able to understand. This is the key to the animation. This function here, as far as I can tell, this is like the core. It's maybe like 0.5 seconds through the animation, so it's able to work out where the position would be as it's moving between the 2 keyframes, the first step and the final step. Same with rotation, and same with scale. Although I don't understand how scaling works, because a lot of things that animate, they don't scale, they just move. As the airplane's moving, it doesn't become bigger or smaller. Is this your first game called Duck, or you've made a few before? Okay, just let me check the stream. Sometimes I'm streaming, getting carried away, and you can't hear me. Also, I can see there's 10 people watching, 11 or 12. It's changing a little bit, but feel free to recommend some better music if anybody wants to. Okay, let me load up the engine, by the way. Some of you haven't seen the engine. Oh, I love an error. I don't know if you can see the error. This is where you learn. Okay, unresolved external symbol, interpolate rotation. No, I'm pretty sure. Did I not write those functions? Interpolate position. No, I didn't. Okay. I think what I need to do is, let me just see if that will allow me to skip it. yeah. Just every now and then it's good to just load up the engine. There's a lot of new people coming into the chat, just so you can see what's popping. There's not too much to see, but there is something to see. Like the cat. Shout out the cat. Hello. Say hi to the stream. Say hit subscribe and like, and I will feed the cat. It's just a joke, Karen. Relax. Shout out Karen. Okay. Everybody go check out Cool Duck's channel. Cool Duck, you better have something for us to see on your channel. But not before you hit subscribe. Okay, let's just load up some terrain. And maybe we can load in some, let's see, actually I just want to check what textures I've got just to show you. So keep loading up the same. So I'm just pulling up on my screen, I don't think you can see this. Now that would be an unusual one, but let me just try that. Brickclad.jpg. Is it a JPEG? Or a PNG? Okay. And then we need to change the blending. So that's not, I mean, that's okay. Let's get some light in. But I can kind of see that being used as, imagine, that could be like a mineral that your people mine, like a resource. You'd want it nice and shiny and so on. I want to say it's not great, by the way. I do want to acknowledge that. What else is there? Coarse sand, cliffs, dry mud, grass texture, grass mix, hill. Shout out hill. Let's try hill. So I just want you guys to see a little bit of what you can have. Is hill a JPEG? Yeah, if hill's a JPEG, it's gonna just pop on now. Actually, that's pretty nice. Let's take the grid away from the water. That's hot. I like it. It's quite simple as far as what's going on with the lights and shadows and the sunlight and so on. Okay, let's just generate a terrain that's 10 times bigger. The water's probably going to disappear. And then, okay, so now we have this is a very large world. It won't look like it because we're so far up we can see the end. But it's actually quite large. And then we want the amplitude much higher. We might destroy stuff here. Okay, it shifted the camera and the world's gone higher. That's just a noise generation. Okay, now that's more of a scene, I would say. A lot more of a scene. Let's get more grass. And that slope needs to go to change. So that is pretty cool for a little terrain engine. We need to generate less octaves, I think. A bit smoother. And maybe one fiery sky. What else might you do? You might have sand. Okay, so what's black is where I've not loaded the second texture yet. So my default is mud, which is just optional, and then that's not a shadow. It is a particular angle, so it's a certain angle that's not rendered, which I change on the slope, like the steepness. But then what I do is I load another texture into that. It's not the best texture because it's repeating, but it's a sand texture, and that's a pretty decent. You want to sort a few things out with the loading. It needs to cull, which means it's drawing more than it needs to. There's things behind the scenes it's drawing, and it's drawing the same quality for things in the distance, which is also a bad idea. Yeah, my tools are taking up a lot of memory as well, but I would say that's a bit of a terrain engine going. It looks like the camera's moving very, very slow. It's actually because the world is so big. I made it 10 times bigger. You'd want something half the size of that, and generate it now. And it's just too high now. And then we'll go back to the origin with this button, and we get a nice crash. It wouldn't be programming without a crash. GDD is yeah, what's a GDD, brother? Help me out. Also, I need something in the API that tells me when somebody subscribes, so I can give you a little shout out. Actually, shall we just see where this crashed? I don't know if you can see this. Let me bring in the... No, you can't see this. So in that case, I'm gonna just cancel it. I don't want you out of the ongoing story. I feel like we need to fix the music, so we're going to say copyright free music from YouTube. Copyright free music. And then we've gone in with Halloween Jazz. Looks like the same company that's providing this as the last one. It might be just as bad. Yeah, it does feel... No, I've never done a game design document, but yeah, I think you need to do that at some point. It doesn't have to be in a traditional way, but whether it exists in your head, whatever works for you, I would say. But you do need something, which is my opinion. Also, Trello. Trello.com, I think it's free. There's free versions, but you can just set up. Check it out. It's like to organize yourself. Okay, where are we in the code? We're going to go back to animation. Let's get all this back in. I just wanted to show, sometimes some streams fall into the trap of just not showing anything. Too much coding. That needs to go there. But what I will do is these functions that we're missing, I'm just going to copy and paste them from the code we have, because it's not meant to be a teaching stream today. Interpolate scaling, and I would just go for it myself at another time. So this function here, if you press control and full stop, it'll bring up a menu, it'll bring you this, and then you can just get your code in there. And then the other one was interpolate rotation. Control and period, control and full stop, and then it will give you that, and that was rotation. That should be everything. Okay, we've got a basic error now. Oh, actually that looks quite ugly. But no times. I need to do an overload there. Maybe there was one. Okay, let me bring you back in on the ChatGPT that we're going through. And we're discussing an error. No operator matches these opera hands. It's going to tell us what's wrong. Where is the multiplier there? Start end. Yeah, ChatGPT's got better, although I don't understand what it's done there. Interpolated. Here. It's here. I was only looking here. Okay, interpolate. So first off, it's got the scaling wrong. So let me say it's referenced the wrong function, but it's fixed the bug. And now we'll just talk through it now, what it's done. But I think it's basically operator overloading, which it's going to give us. Oh wait, is that for real? I might get ChatGPT Plus. So what's happening is we are trying to multiply. And what is end? End is an AI vector. So there's a type of data or a structure called AI vector 3D. We've given it the name end. And we're saying, so 3D means X, it's got an X, Y, and Z component. So we're basically taking the X and we're subtracting the X component of the start 3D vector. But this is a custom data type. So how can you, you can subtract 5 from 7 and get 2. But how can you subtract AI vector.x from AI vector.z? What does that mean? It's not maths. So you have to define how the operators work. So this was shown here. So and this is a signature for overriding, or it's called overloading the operator. So you in C++ you use the operator keyword and then the operator. And then I think I've not done this for a year or so. The operator on the left, I believe the operator on the left, times by the type. Let's go back to the code. Yeah, so this was how much, so 5 multiplied by the type of object it is, and then you define that. You define what type it is, and you define how it works. So the number, let's say you're sending the number 5 to multiply, and then you send in the type of object you're multiplying, and then here you're teaching it how to multiply an AI vector. And let's have a look. You're saying the way it works is you take the first thing you send, which is the factor, and here it will just be something with the animation time. So let's say it's ultimately the animation time, how many steps through. So maybe 2 seconds. So where you've got a scalar which will be 2 seconds, you times the x component by 2 seconds and the y component. So you break down the AI vector into its x and its y and its z, and then you send it back. So you do all the maths in this function, and now I'm going to take that AI vector. Now where do I need to define that? I don't think it matters actually, because let's put it here. I think as long as it exists in a unit somewhere, I could be wrong, it's been a while. Now we should say that's ChatGPT fixing it. I understand how operator overloading works, but that saved us time, right? So now we can multiply 3D vectors by different types. And the last time I used operator overloading was when I did a server for a 2D game. And for those of you that know what a packet is, when you're sending some packet information from one computer to another, maybe you're sending a bullet, you're shooting, and you're sending a bullet packet, and it goes to another computer, and it's like a bullet has arrived, and it's like how does the computer interpret bullet information? A bullet's arrived, it's got a position, a speed, a velocity, a texture, and then you might interact the bullet with something else, and so you're overloading operators to describe how these interact in the clients. So that was the last time I used operator overloading in defining packets. Okay, ChatGPT, we'll do a new chat, we don't care. Because we have that now. Let's open an animation. So you can't see this, but star.fbx. And we will open, I think, the wolf. It's just loading. Those are my lights, and if I change the type of light they are, they will move around. And we have some wolves turning red because I have red lights. Now they're blue and red, depending on when the red light gets there. Okay, so now we have some wolves that are rotated in unusual ways. That's just how somebody drawn it in Blender. But we also have here all the types of rotations and animations. So the animation's still working. Animation 2, bone, AUG. What's an AUG bone? I don't know. Actually, this is just probably German. Deutsch, it's just a different language. The root. But everything is loading in, all the names and everything. So I'm just saying the code's still working. I didn't destroy it yet. And let me do this. And then this. There you go. And what I need to do is... Okay, so this was the wolf that I was editing. Why is it rotated so bad in Blender? I think I just want to open up Blender and fix that. But that's a bit boring on a live stream. We don't care about your rotation, wolf. Because I'm gonna draw my own people. Okay, how long's the stream been going? 2 hours and 40. I'm gonna have to go for at least 3 hours. I don't know how some people are doing 5 and 8 hour streams, man. I don't know what's wrong with those people. But I wish I had that affliction. Okay, so what? Let me give this to ChatGPT. I want to see. It's saying I need to do a new chatbot. Actually, I might have just not finished. No, I didn't. Interpolate scaling. Hello, cat. This is cat number 2, by the way. She is more demanding. It seems you've been inadvertently declared interpolated twice in scaling. Yes. Yeah, because we've overloaded it, this could do it all. You don't have to do individual components, I think. Either is the same. And we need to finish. Let's have a look here. Wait, why won't it let me scroll across? What has happened? Oh, that's in the way. Sweet. Update burn transformations. So we've got the current transform and then burn transforms. Name equals recursively call the children nodes. So we're going to go back through this function. So now this is calling the function that we're already in. We're sending the time, and then we're taking the current node we're working on, and we're getting its child, so 0. So it's going through an hierarchy. Yeah, all good. Just finishing the update transformation function. Oh, hello. So the same thing really, for some animation. ChatGPT didn't like this function. Let's have a look. If your keyframes are numerous and performance is a concern, consider using a binary search approach instead of a linear search. Since keyframes are typically sorted by time, this can be significant in reducing the time complexity. To log in, here's a basic binary search implementation. Okay, I'm just going to take that. Okay. Edge cases. Does that consider edge cases? Does the latter consider edge cases as well as big O? Okay, yep. So ChatGPT is saying consider creating a method for managing. Let's have a look. I'll bring it in here. For managing animation playback, which will help control the flow of time through the animations. Okay, so the big question I have now is how does this apply? Apply to the model? And I think really I just need to be passing the time. Okay, so as I load, for example, the wolf animation, it just draws a 3D render. How do I apply one of the given animations? Let me just pull out my... We'll go with that for now. I could do with sending it my render function. Load the animation, get the time. Okay, so I need my shaders. Let's have a look. Model vertex. I'm going to say let's cut this. It's going to know what it is. To implement skeletal animation, you need to modify how you calculate the final vertex position, which is here. So let's see, calculate the final position of the vertex using bone influences. Okay, so that's interesting. So what we're sending in here, the weights. These must be. They're not the matrices. Interesting. So I want to know for my own learning. Maybe these are the matrices. Given my above C++, where I'm creating and multiplying matrices, where and how are these exposed to the shaders? I think it's just the model matrix that we just send. Yeah, here. Or maybe here, yeah. Was that in the above? Maybe it was, I missed it. Yeah, so I don't have this yet. So this is an array of bone transformations. Max bones, instead of 4, it should be defined. Second. Yo, 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 yo. Boom. The kettle's on. The kettle is on. That's how English we are in here. 3 hours in. It's like tea break, 3-hour tea break. Right, I need to get this screen on. Let's see, we've got the backup. This is the command center here. Little portable thing. And we lost power somehow. What was taking up? I think it was this and that. Let's try that. Try that. Yes. Load in. Yep, we have 4 screens. So this is the thing with laptops. Sometimes some USB ports have more power than others, and I think it's working, maybe not. But it doesn't really tell you in the manual. Somebody's chatting, I can't see your name yet. It's the Homer. Yo, yo, yo. Wait, I've just got a crash there. Is that on my side? My screens are turning on and off at the minute. I hope the stream's still on. Yeah, I think it is. Part of the camera's dead. Yeah, I think we're gonna have to lose that screen for now. But what I might do, yeah, the camera will come back. It's just it'll come back. Yeah, I think I'm gonna leave that. I don't want to crash. 1 second, I'm just gonna get my cup of tea. The kettle was just boiled. I think there's probably some ugly screen there. Nice. Nice crash right there. Now if I think I can turn the stream off, but not the YouTube side of things, so it should just continue. Let me know if you can still hear, and if so, I'm just going to restart. Sweet. Okay, so I think I can shut my streaming software down, but it should keep up. Yo, 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 can you still hear me? I think we're back in now. Yeah, sweet. How are you? And what did I work on? Yeah, I got some animation tools in. It's not working yet, but I can say it's not broke, it's just not finished. So that's not bad. Control and paste that. Sweet. It's a strange one. Okay, the important thing for me was just to not let the stream die. The algorithm just likes a longer stream. Okay, let me just... These cats are killing each other. Yo! Kill each other quietly, man. So this is where we left off. Shaders. I hate shaders when I'm tired. You can't just throw a bit of code in. Shaders are sensitive. Hey! It's 2 AM. Okay, I've got an error. Oh, what's wrong with these cats? Music's loud. Did I get that wrong? I've never seen him fight before. Right. Stay. Where's your sister gone? Brother. I'm just looking after some cats for a friend. Oh, what's the error? Maybe it's just a node. Oh, that's a vector of map 4s. Hey! What are you fighting for? Hey. You wanna fight? Move. I think it thinks it's a map. Bone transforms. Bone transforms is a vector. Should it be a map? The cat is chasing nothing. Oh, it's freaking me out. Did I change the name? Let's just run it. Bone transforms is unidentified, undefined. Oh. I should include unordered map. That'll do it. used to work. Red mug. Okay, let's open up a animation and see if we still have the data. Wolf.fbx. So that's what we've added today to the engine. I've updated the asymp, and now it will take extra file types. There's like maybe 50 files, but here I think I need to make the writing bigger for the stream. But yeah, this is loading the animations. Okay, it's all there. There's a deranged wolf facing the wrong way. But it is facing the way that it was drawn in Blender, so it's facing the right way for the file. Okay, that was a bit of a slow 20 minutes as suggested by the timeout, but I'm back. See if I can go for an hour. By the way, if you subscribe, if you hit like, if you give a comment in the chat, it encourages me, but also it helps the algorithm. It brings other people in. You don't need to. We're not about paying donations to say thank you. You can just say hi in the chat, and it will bring it tells the algorithm that people are talking, and other people will come when you leave. If you don't like it, give a thumbs down. Also helps the algorithm, because debate is also profitable for YouTube. Okay, so let's close the engine and go to continue. Okay, so what we need now is to get some animation in. Animation.cpp. By the way, this is a cyberpunk theme for Visual Studio that we're using. Okay, chat. Okay, chat. Given that I import a model with animation, I tried to do this a minute ago, but the stream died. And this class, how do we start an animation? Yeah. This is not really the kind of thing you want to teach and go through and learn live, really, for a live stream. But I was gonna learn it anyway, so why not stream it? But I just don't have my full focus on the stream. Load the model and animation data. Initialize the animation controller. Create an instance of the animation controller class and initialize it with animation data from a loaded model. That makes sense. I'm just wondering whereabouts I would put the animation controller, to be honest. Structurally. Animation controller. I think I only need one. Current time, animation speed, Okay, so let's go to the. Actually, I want to speak to ChatGPT about this. Okay, so we have a model loader class, and then ultimately in main we loop one of its vectors to render the models. It may be X number of models. Presumably we need only one any controller. How might we relate them? So it's suggesting a single instance of animation controller. So we've defined an animation controller, but we're not using it. We've just created it. So now we want to bring it into main. Okay. You have a single instance of it. It updates animations based on the models being rendered. Each model can have a reference to its associated animation data, which the animation controller can use. I think what it needs is first here is the model loader. Here's the model loader class and main. One is the shader program, but it's not relevant nor used there explicitly. Okay, so I'm just giving ChatGPT my current context, how we do things, and then it's going to adapt to this. We don't want to move away from this too much, not for just my first engine. Thanks for providing the details. Now let's discuss how to integrate. Define the animation controller. Are you suggesting one controller for each model? Model name, okay. Model loader. This is the model loader. We already have this class. We already have this class. Here is its header. So now I see the need for ChatGPT Plus because its memory is bad. So maybe I'll pay for that next time. already have the class fleshed out, I want to integrate the controller into main and start to move models, animate. Right. Hello. Crazy cat. ChatGPT is just on some, I don't know what it's smoking, but it keeps telling me to do things I already done and already have. That's all good. I'm just going to put it in main and start to go myself. It's all good. Okay, chat. Create a controller animations. Load model and animation. Where is that? No, I already have that. Render loop. Yeah, so this is what I need. Okay. What I'm curious about is how it selects, how I would go through different types of animations. Yeah. So let's include animation. Maybe I already have it. And then what we want is, do we have a delta time? Yeah, we have a delta time. Okay, let's get an animation controller going. And that should do it. Backbone transformations. Okay, so within animation controller, where do we have the animations? Animation data. So when I load a file, it goes into here. So if I go to, let's have a look, model loader, bone, and then we go to bone animation, go to the bottom, and then with animations that push back. Yep. Animations is undefined. I don't think that's true, unless it's animations new. I think it might change the name. Animations new. Animations new. There's another one here. Nice. Animations new. Animations new. I think that's just been animation data. Maybe in the model loader. Model loader. I'm not sure that's going to work. Nope. This might need to go in a CPP file. Animation.cpp. And what we will do is we will put it in animation resources. External. Also, I don't know if animation header has access to globals at the minute. This doesn't know about animation data, I don't think. So I need to tell it it exists somewhere. I've spelled it right. There's more errors, by the way. unresolved external symbol animation controller. Which is defined in animation. Which is there. And then it might be the constructor. But why does it need to be found? We don't always have constructors. Is it because I've mentioned one? Sometimes when you mention it, you have to define it. Let's put the laptop on turbo mode. It's just sometimes noise. There you go. It was the constructor as well. Okay, so what did that do? That started to initialize a few things. By the way, if I open the object file, does it give me... No, it doesn't. I was asking, does it give me the animation data? At least it loads them the right way around in the FBX format. But I don't know why it wants to look so crappy. Go through the submeshes. Which submesh is this? The eyes. That's why we can't see. The wolf object body. This is my little viewer tool. Crappy little tool. Interesting. Why did it load with 0 transparency? That's the fur. Specular. I think this is like, there's different layers to this file. So this is the body, the main body. Doesn't seem to have a texture. Yeah. But yeah, this is not the main wolf file anyway. This is an FBX, an OBJ one. But yeah, whatever. Sometimes the light, there you go. Sometimes the light can take it out. So we need to instantiate a few more things. We need to set up some things. So main controller. So now we have the animation controller. The great filler word. So we have the controller. Do I have last frame, by the way? No, last frame equals current frame. Interesting. That's not right. Current time, okay. Delta time. Current time, take away the initial time. Oh, that's fine. Initial time can be that time. Bro, how did you code this? You're already tired. Yo, yo, yo. Where are you calling from, Homer? I'm gonna eat an apple, so I'm gonna drop the volume. I did it with a lot of help over some time. So what we need is animation controller pointer equals animation controller, because this code isn't going to work like this. So we need a variable, this homeboy here, in global, which is going to be class animation. So this is forward declaration. This is telling it that there's a class called this somewhere, and then we're making an external animation controller pointer for animation controller pointer, and it's external. And then that's the homeboy there. So now every file, all of these files can access our one animation controller by using the animation controller pointer that we created in globals here. I might have done that wrong, but let's just see. Wow, apparently I had 3 microphones on and nobody said anything. That must have been bad. Unresolved external symbol. In main. Let's make sure there's no typos. Let's go to main. Equals no. I don't think that's the issue either. on, bro. I think what I need to do is that, because it's external, I just need to declare it in like an open scope. Pointer to access animation controller globally. Pointers have we got here? Oh, what a dumbass. What a dumbass. That might not have fixed it, but it's fixed one thing. We're getting there. Beautiful. There we go. Okay. So then what did we need? Okay, we need this. So within the render, we need to update. So model loader new. What I'm going to do is give model loader new model loader new needs animation controller pointer animation controller equals animation controller pointer. There you go. But that needs to belong in model. Yeah, that's a big class. Wait, where are we? What we're doing in main? Just need to include the header file as well for this to work, I think. Why did that work? It might not work once I try to use it, if I'm honest. Animation controller. Excuse me. Okay, so what we need is so now if we go to main here and go to model loader, no. That's inside the constructor. There you go. So now model loader new as an animation controller. Okay. So then what we want to do within render maybe. I think we can do it here. Assuming I will pass the frame time to this function too. I've also given it access to the animation controller pointer. Can we use this render function inside of main, which is rendering every model, submesh, to move the animations. Delta time. So this function wants to know also the delta time, so let's update it. Just the flow basically. And if we go to main, we will pass also delta time. Interesting, static total time. I think animations new is global. scene. Yeah, we don't have access to the scene here, which is interesting. It's not interesting, it's annoying. So model new vector. Pointer, model ID. So model new vector is model new. Yeah, I need to be extracting more data when I load. But I might just hack this away to see if we can animate just one model. When I load scenes, I don't afterwards have access to the scene object, but I just load animations, etc. into the into structures. It's all good. I updated my vertex new for animations, but maybe I need to update model new to etc. Bear in mind my model loader class does extract all the data, but only puts them in the struct for vertices, etc. Maybe I need to encapsulate some in the model new also. Animation, data, references. Hey Nico, what's going on? Actually, I used to have a really close friend called Nico. All good here. It's been a long, I don't know, maybe it's 8 hours coding today. No, 7. going to say 7. To effectively integrate animation data into your model new structure while maintaining a clean design, it's essential to encapsulate the relevant information. Right, do I have animation clip already? Animation clip. No, that's not necessary. Okay. Model pointer. Update animations. Okay. I don't think I have an update animations function. this is the one here. We need some better music. Okay, total time's in, static time. See, I've got everything in the code now as a structure. I just need to tie it all together. And I've been asking a lot of questions because ChatGPT, because I've started a new page, it doesn't know what I have and haven't got. So everything it suggested was wrong, and I've just given it where we've left off. So it's going to be able to help me, I think, now. From render, total time, we've got. And we're here. Controller point update bone transformations, animation time, model, pointer, yeah. Let's see, where does root node come from? Model pointer, root node. And then here it wants, what does it want? AI matrix. So because this is the first call, we'll just send a constructor, I believe. Model pointer and root node. I think that's everything, but this doesn't have root node because, come on, Henry. There's a pointer to model new. Model new. cases where file sizes are just getting bigger. This version. Sorry, chat, I lost you. 1 second. That should be it, to be honest. I kind of know, I know what I'm doing here, but just after it's yeah. I guess it's not called model. It's called mesh pointer. It's not, it's init mesh. Init scene. Forgot what the parent function is called. All meshes, yeah. Bless me. We live. Okay. So we're doing model, this should give it as here. What was it called? Root node, there you go. Model root node equals scene m root node. So now all of our models will have what we need. So here, watch the magic. Root node, there it is. But you still want to give it one of those. That doesn't mean it's going to work, but we have made progress. I don't think the shaders, I don't think the shaders are ready to handle it. Also, what was that little error there? I saw you. No, we're good. Loading some animation files. We don't want to be crashing because who wants to debug? Node name. Max pointer is null. So this will be model pointer. getting that far though. This far. Let's find out. Excuse me. I need to have this find. I have to keep typing find FBX file type. Okay. Let's see if it typed the comment this far. Yeah, so it did get to. It did. It printed this, which means this took place successfully. To do submesh, middle pointer, submeshes. Have I changed mesh somehow? What was we doing? Init mesh. All mesh, yeah. I just don't know where this is going wrong. But that's okay because I do know it is going wrong. See, if it's going to crash, it should be on the new code. What we get, this draws to, this is a bit of debugging, it writes it to the screen. Model pointer. I don't think I changed any of that. So we're going to load something that's not got any animations and we're going to see if that crashes. Probably will. Yeah, but that's interesting because maybe this is the reason it's crashing. But yeah, this doesn't have any animation, so it shouldn't have got that far. And maybe that's the point. If model pointer get root node dot how do I render it in the nested loop, but first check the what was it called? Root node as animations. Error checking, always error checking. What does get seen belong to? What a point to get seen. thought it was part of asymp library, but it was just creating it basically. So the returning of loaded scene should be 1 per full model. This is pretty simple, but I just thought it was doing something else, and it wasn't doing something else. Model new. Return AI scene. Let's have a look. Yeah. So it's returning a reference to the scene. Loaded scene. Yeah, loaded scene can work. So AI scene, loaded scene equals no poir. And then we will go to init or meshes, and here we're going to say model loaded scene equals scene scene, right? They're not working, homie. Going to be because of the type, maybe. Oh. I love these typos. Here. I didn't know you could do a const cast. So it's protected with const. I wonder if that's safe. It looks like like I broke something in the loop here. Okay, we have that working now. I think there's just that. Now there's 123 errors, that's what we like, right? Wild. So why would it go here if this function of animation is greater than 0? Wait, what? No. Still not going to fix it because it doesn't have any animations in the house, but it still seems to think that there are. Access violation, reading location. Okay, so it's crashed on a different part, which is good because this part it shouldn't go to. But let's just check the scene. Can we access the scene now? And what's crashed here? Access violation. It might be the const. Might need that one gone as well. I had that before. Access violation, animation time is there. No children 1. No children 0. Where are we here? Is this update bone transformations? Render submesh, update bone transformation. Why are we updating bone transformations? checking the wrong thing. Num animations dot. Oops. Did I kill anything there? Has animations. This might be different. Also, a file could be saved with having animations that just doesn't move. But there's something else going wrong here, I'm sure. Okay. So that makes sense. It has no animation, so now I think we'll open the wolf and I think it will crash, but for any other reason. Okay. Let's have a look. So there's 3 children, so that would be 0. Update bone transformation. Update bone transformation again. Name.data. So really what we need is, so what happens if there's not a name? Is that possible? There are 3 children, it's calling the recursion, then getting access validation on the name of data. Got no input or output stream. Now we have. start, as long as you've got async set up, just